This is 4.1, the law of sines and law of cosines. If you will recall, when you had right triangle trigonometry, there was angle A, angle B, and angle C. And the side opposite the angle was always named the little a, side of A, and the little b and little c. So it was the side opposite the angle that got the same letter. Your sine of A was the opposite over hypotenuse. Cosine of A was the adjacent over hypotenuse. And the tangent of A was the opposite over the adjacent. Sine, cosine, and tangent are actual numbers. Okay. For instance, let's look at the standard 3, 4, 5 triangle. That's a Pythagorean triple, so I know it's a right triangle. And what we've got here is sine of A is 3 over 5, which is 0.6. So that is somewhere right here. If the sine is 0.6, it is somewhere between 35 and 40 degrees. So it can tell you, because of this number, what that angle is. But the sine of 35 is 0.57, so it's pretty close. Then you've got a cosine right here is 0.8. So I'm looking under the cosines 0.8. That is very close to 35 degrees. Maybe a little bit more than that, but very close. Okay. Let's see. I have got the sine right here, the opposite sine of whoops, need to clear it out. I forgot I was doing it that way. 0.6, and you take that. So it's 36.86. That's what that degree measure is right there. Okay. You would do that for the cosine, and you'd have the 0.8 with the cosine. Get roughly the same thing, 36.86. Okay. So, yeah, you would get the same thing because it's the same angle, A. Okay. Do it with the tangent. You would also get the 36.86. That's 0.75, and that's going to be, again, right between the 35 and the 40. So these are actual numbers and actual angle measures that we're dealing with. Now, when you've got these kind of things right here, they're otherwise, especially when you don't have a right triangle, you'd use the law of sines right here. Sine of the angle A over A equals the sine of angle B over B equals the sine of C over C. Now, you're not going to use all three at once. You would just use 2 out of the 3, depending what you've got. When you have 2 angles on one side, this is where you go. When you have 2 sides in one angle, this is where you go. Now, the law of cosines here starts with the side A and ends with the angle A. If it starts with the side B, it ends with the angle B. And if it starts with the side C, it ends with the angle C. You'll notice that all of these are set up just like a Pythagorean, the a squared plus b squared equals c squared. It just depends on which one is outside. A squared equals b squared plus c squared minus 2bc times the cosine of A. And remember I said the side and the angle match up with that. B squared equals a squared plus c squared, the other two, minus 2ac times the cosine of B. Okay? C squared equals a squared plus b squared minus 2ab times the cosine of C. So that is what you are looking for. Okay? This right here, is slide 3, even though I added 2 before I did this video. This is an example. The next one is the one that you have on the assignment that you need to turn in. You'll be doing it pretty much just like this. You've got 2 angles. The triangle angle sum theorem is that the angles of a triangle equal 180 degrees. So if you want to find all 3 angles, you add the 2 you've got, 141, and subtract it from 180 degrees, and you get 39 degrees. So this angle right here is 39. So you found all 3 angles just by using your triangle sum theorem. And that's what they tell you right there. Okay, so finding the sides that we've got. Sine of 39 over C, which is unknown, equals, now I don't want to use the A here because that's also an unknown. I wouldn't want 2 unknowns in one equation. I would use this one because that is totally known. Sine of 93 over 15. To find the C, you would cross multiply so that 15 times the sine of 39 equals C times the sine of 93. Now, like I told you, this is just a number. Okay. I don't go up to 93 on this one. But it's just a number, just like sine of 60 is a number. And we are going to then divide by that sine of 93. And since it's the same number on top and bottom, you can cancel that out. So your side C would equal 39 sine times 15, and then divided by sine of 93. That gives me that C equals 9.4. And you usually use a tenth marking on that. So we have 9.4 for C. All right. So the next one, we still use the sine of 93 and the 15 since that's given to us. And we don't have anything that we are rounding off like we had to do here. That one equals, and now we'd have the sine of 48 over A. Cross multiply and you get A times the sine of 93 equals 15 times sine of 48. So once again, you're going to divide by that sine of 93 because that's the number with that A that we want to solve for. Divide by sine of 93, and A equals, so let's move this over here. I have the sine of 48 times 15 divided by that sine of 93. So my A would equal 11 point, I'm going to round that up to 0.2 since that's a 6. So I would have 11.2. Now I don't know if you guys remember this or not, but the side opposite these angle measures, the smallest side will be opposite the smallest angle. So 39 and 9.4, the middle angle and the middle side will match, 48 and 11.2, and the largest angle is opposite the largest side, so 93 and 15. So you definitely got the right, you hopefully got the right answers, but at least it matches up in terms of small, medium, and large. So that'll be the first video. On the next slide here, this is your slide 4 that you're supposed to turn in on this assignment. So do what we did on the last one and put this on your assignment.